Hey guys, really fast want to show you a couple of things that we've done even back into 9.1. So in 9.1, we were asked to find the solution to an IVP. We were told the family of solutions was y equals 1 over x squared plus c, and you can type that right into Desmos like so, and you notice they then ask you to, if you want to add a slider for c. So they recognize c as an arbitrary constant. So kind of fun to add that slider. This one starts with c equals 1, and if you hit play, then it goes through different values of c. And it's kind of interesting to watch. This one goes from -10 to +10. Any positive values of c, you just get this kind of bump. But when c goes negative, now you've got these two vertical asymptotes that occur. And if we kind of draw it back, like when did that occur? So it was like right at, I'm trying to like hone it in on 0. 0 would just be, the vertical asymptote there on the y-axis. But then as soon as c goes negative, now there's two vertical asymptotes just due to the nature of that function. Okay. So what was special about our question? So our question said, okay, so out of all of these functions that it's running through when it's doing these different values of c, which one passes through the point 2, 1/3? So we can see 2 1/3 right there, and we can see, okay, there's only one function that's going to pass through that point, and it happens to be what we solved, where c equals -1. So if I say, all right, well, let's try and make, if I can get it, there it goes. So when c is -1, it passes right through that point. And so we put -1 in for the c, and that was that. Okay, pretty interesting. And then the only other thing was that orthogonal trajectory, which is really the only other thing. This is huge. This is so cool. All right, what we're going to do, we're going to put in y equals x over 1 plus kx, and it recognizes that k is an arbitrary constant. So here is the family of curves with k, and notice there's something special here about positive and negative values of k and the way that thing looks, and it kind of swings around. All right, so we eventually got down to our orthogonal family, which was y equals cube root c minus x to the third. So I'll just do the cube root as raising to the 1/3 power, like so, and we can add the slider for c. Okay, and notice that where these families intersect, it's always a right angle. So here we've got, we can see those right angles there and there. Pretty cool. So what happens if we let the k just play at this point? And wherever it crosses, it's going to be a right angle. So even as it goes through all these different values of k, every time it crosses our orthogonal trajectory, it's always perpendicular. Now, what if we let the c run? It's going to be the same thing. It's always perpendicular for every value of c where it crosses. So every combination, and now what's really cool is when you let them both go. And everywhere it crosses, it's always a right angle, any combination of c and k. So there's your orthogonal trajectory. That is really something interesting. All right, let's stop this video here. Go have fun with the homework.